is going to be 1.4821. That's it.
So can you show them the transfer function, like k divided by tau s plus 1?
Yep. And with the value of tau and the DC gain, we can calculate the transfer function of the motor. It looks like this.
Okay, great. So now I'll go ahead and show them the GP6 connections. Hi, so I'm going to show you the GP6 connections now. Initially it's a difficult machine to understand, but once you get it figured out, it's not that difficult. So it has basically 6 channels, 1, 2, 3, 4, 5 and 6, which are nothing but 6 amplifiers hooked up in various configurations, and you can make circuits out of them. There are also 7 or 8 potentiometers, inverters, multipliers and all that. One of the things about this is that the symbols are in international conventions, so they do not match with anything that you learn in normal electrical or electronics. But no need to get worried about that. If you read the manual for the GP6, they have the whole patch panel, which is this, and they show you how to make connections. You will need to look at the manual yourself and figure out the connections that we need for this equation right here, the one that I showed earlier. This is the one we are going to implement. As for now, I'm just going to walk you through the connections, and when you look at the manual later on and maybe play this video, you will understand why we're doing it this way. Okay, so the basic prerequisite for working with the GP6 is having these wires, these 2 terminals, shorted on the channels that you do not use. Okay, if you do not short these, you are going to be overloaded. And I guess we have a missing wire, and I will fix that. So all of these terminals, 1, 2, 3, 4, 5, need to be shorted because they are the channels you are not using. If you short these, the GP6 understands that you are not using these channels. For the channel that you are using, as we see we are using this last one here, this channel, these 2 terminals, SW and OP, need to be shorted. Okay, this is the basic setup. Alright, once you have got that fixed, let's say this red wire is the input, which goes to the first potentiometer. Okay,
It's going to be number 5.
it's going to be number 5, and part number 5, and this we adjust the value of part number 5 to k divided by 100 tau because it's the first part. So the output of this part goes to the integrator with the gain of the 100, and then you have this shorted. Then this wire goes up to this place over here, and it's basically the output of the integrator, the red thing. And then the output goes to the inverter, and the blue wire takes the output back to the Quonset board, and the output from the inverter gets fed back to another potentiometer. This potentiometer number 6 will have a gain of 1 divided by 100 tau, and then the output of this part goes back to the integrator again. It's a fairly simple circuit. However, these 2 are the ground terminals. They must be shorted, and you have to hook up the ground to each of the connecting wires. Let's see, let me give you an example. If you look at the input wire here, you see the red one, the red coax cable, is carrying the input signal from the Quonset board. So this red alligator clip takes it to the input wire, but the black wire, which comes from the outer terminal of the coax cable, goes to the ground wire. Okay, and a thing to note about this is that you must not connect the ground on the input wire to the ground on the output wire, and then just hook a common terminal back to the ground, because if you do that you will create a ground loop. Although that is electrically feasible, but many students have run into problems with this, so it should be avoided. And if you see, these are the two ends that will go into the Quanzer system. Another thing we are missing in this connection, and I will do that right now. If you look at the GP6 manual, the IC terminal, the input at the IC terminal gets subtracted from the inverter output. So it's always a good idea to ground that, because you don't want any subtraction happening in our equation. Because with analog circuits, you never know if there is some offset null, if there is some quiescent current or some noise from other sources. So you should always have IC grounded for the channel you are using. Okay. Now we'll go ahead and show you the operation.
I'll show then the potentiometers.
Yeah.
The board.
So,
1, 2, 3.
So these are the dials for the potentiometers that you have here. So we are using port number 5 and 6. So port 5 and 6 are here. You can adjust these dials to adjust the gain. And this is the port address. You move this knob to either 6 or 5. So if you move it to 6 and then turn this, then it will set the gain for that port. You move it to 5 and then turn this, you will set the gain for port number 5. And sorry, the previous one was 6. We are not dealing with the X address over here. When you are setting the potentiometer, this knob, the mode selector, has to be in the port set position. When you are running this and taking data from it, this has to be in the operate position. Okay. To turn it on, you just turn this dial and keep it to, like, say 40 or 50 as the compute time. Those are the best settings according to our experience. It's mysterious what these buttons do, but leave them the way they are. I think IC or OP, if you hit one of them, your output goes completely blank, which is not a good thing to do. So we'll just leave them the way they are, and we know it works, so you got to trust us on that point. And if your connections are alright, then the overload light should not glow. However, there are some GP6s in which the overload light keeps on glowing. Like, see, this one does not have an overload in the port set mode, but if you put it in OPR, oh, this one doesn't have an overload light still, so this is one of the good ones. But if you have the overload light on, and most of the GP6s in the lab are marked saying whether they are always overloaded or not, because that may just be a malfunction, but there is no bad effect on the data. But if it's a good GP6 and the mark on the GP6 says that it's not overloaded, then if your overload light is glowing, you are either giving it wrong inputs or you are hooking something up wrong. Another thing to note is these are sensitive devices, so please do not plug them into any power supplies higher than 110 volts, because that will burn them. And that's it.